Hi, we are Techie Treads presenting our Spring 2020 capstone project, Amani's Modified Treadmill. I am Jessica Bash.
I'm Tui Ha.
I'm Rachel Kelly.
I'm Jenny Lee.
I'm Renmar Sariel.
And I'm Jason Vanisco.
We have created an accessible treadmill for our client, Amani Graham, a 37-year-old partially blind woman with dwarfism. Our task has been to modify an existing treadmill to fit her height and visual impairment, and also to fabricate guardrails to allow her to exercise independently at home.
In the bottom left corner, labeled as Figure 1, is the functional block diagram, which describes the inputs and outputs of our system, and the connectivity between the two. The overall system requirements for our project are displayed below the diagram. As a summary, our group focused on the functionality and accessibility of the guardrails and display panel to the user. Additionally, we are keeping safety as a main priority by addressing ASTM standards and regulations throughout our design process.
In the center top box, Figure 2 shows our final CAD assembly with the modified guardrails. Below, in Figure 3, is a top view of the modified control panel with altered 3D printed buttons.
In the middle bottom box, we have our guardrail design evolution. We started off with a sketch in Figure 4, which was turned into our first prototype in Figure 5. Our prototype was made out of PVC and crutches. Our final CAD design for the guardrail is shown in Figure 2, and Figure 6 is a 3D printed 1:10 scale model of our treadmill.
In the top right corner, Figure 7 shows the results of the finite element analysis that we conducted on our CAD model. We chose to use a load of 200 pounds because we thought that would represent a worst-case scenario. The maximum stress that our model endured was well below the yield stress of steel, and the deformation of the guardrails was also fairly minimal. Because of this, we decided that the design was viable.
As for future work, all that's left is the fabrication and assembly of the guardrails, as well as physically lowering the control panel. Additionally, further simulations can be performed on the guardrails, such as vibrational analysis. After that, we can further test it to optimize its performance, and we can also include the voice response system. And to finish things off, we would like to personally thank Jim Arnett and Angela Tyler, who are our contacts from VME, for their guidance. We would also like to thank Dr. Laberge for his assistance in answering all of our electrical-related questions. And lastly, we would like to thank Dr. Grianis for all her advice and suggestions.